Alright, so I'm here to talk to you about them graphs in physics. So you know what that graph do. So let's go to Graph Basics, the Graph Basic Training Camp. Get a couple informational tips about graphs. So you have your y-axis and your x-axis, and the line of your graph is your slope. But most people may not know what the area under the graph is. So what's that area? Oh, I'm a meme. It's great. This area is called the integral, and I had to look up how to spell it, and it's the area under the graph. I really don't know why I write everything out when I just do a voiceover. Now, let's look at velocity time graphs, which is from Sacramento to Georgia. So, if you got your car, your Mustang, and maybe you want to figure out how fast you're going, and over time. So you take your velocity and you're putting that all up on your graph. Now pretend that line's straight. I know I didn't draw it straight, but now what can we get from this baby, or graph? Because graphs aren't babies. Kinda. Depends how you feel about a graph. So let's just keep it simple. Start with the slope. So the slope, which is usually represented by m, is equal to 0 on this graph. And slope is the change in y over the change in x. Or here it's the meters per second divided by the time, which is seconds. So meters over seconds squared is what you get from the slope of a velocity time graph. Now meters over seconds squared is actually equal to acceleration. And yeah, I used my phone because I could not spell acceleration, or at least I didn't want to look like a noob on camera, because that's not how I do. But here with this graph has a slope of 1. So on a velocity time graph with a slope of 1, that means if this is still cars, your car is accelerating at 1 meter per second squared. So if slope finds acceleration now, what does that integral find, aka area underneath the graph? And if you think about it, to find area, you're using multiplication, because area is one side times another, at least in this case, because this is a square, and I wanted to keep it simple, like really simple. So that's how you can think about it. It is you multiply both units that are on your graph. So 2 meters per second times 2 seconds. The seconds will cancel out, and that leaves you with 4 meters. Now 4 meters is a distance, and this shows the displacement just from the origin though. And right here I'm going to go into more detail about that origin. So, just drawing this out. So that's why I went to a negative velocity. So here, if you do the area of the top one and then the bottom one, you get 4 meters from the top one traveled, and then from the bottom one you get negative 4 meters. So when you add those together, you get a 0 meter displacement, meaning that you're back at the origin with these velocities. So you got that, boys and ladies, if ladies are watching this. So let's switch it up and get a little more complicated with a force versus time graph, which force is newtons, or kilograms times meters over second squared. So just a heads up here, the slope is nothing important, so we're going to skip it. So what happens, what I'm showing here is impulse, which is force times change in time, which is the integral of this graph, because remember, integral is multiplication of both units, as I show here. So when you multiply newtons, one of those seconds cancels out, so you end up with 4 kilograms times meters over seconds, which is also moment. Kilograms times meters per second is momentum, which is represented as a p. So force times change in time equals the change in momentum, which means when you use the integral of a forced time graph, you can find the change in momentum, also known as impulse. Now this stuff is important, I guess, unless You pick up trash for a living.